To this video. Under physics, we look at the law of motion. This question. A traffic light weighing 1.00 times 10 to the power 2 newtons hangs from a vertical cable tied to two other cables that are fastened to a support. The upper cables make angles 37 and 53 respectively with the horizontal. Find the tension in each of the three cables. All right, so there are three cables and we need to find tension in each. Here's a quick thing. When you see a triangular type of arrangement, just transfer this same arrangement onto an X or Y plane. And here's what you need to know. Before we even go anywhere, take note that we've got tension 1, tension 2, tension 3. But at the same time, we have the weight, okay? We have the weight of this brother, all right? It's here. So the weight of this brother is hanging what? Downwards. Let's call it the force due to gravity. It's always the weight. Clear, right? Now, if I transfer this on the X or Y plane, I'm going to have this type of arrangement. Okay, so this is our Y and that is our X. So if I do this here, but you know the Z property, right? The Z property. This angle is equal to that. So this angle is equal to this angle here. So 37, meaning even this angle here, it's 53. Meaning if I bring this on the X or Y plane, I'm having that. I'm having that. So this is automatically this angle here, 37 degrees. And this angle here is 53 degrees. And this is tension what? 1. And this is tension 2. Where's tension 3? Well, and this is where you need to pay particular attention. Because this guy, this traffic light is going down, meaning even tension 3 is also going down. All right, is also going down. So tension 3 we indicated by this as tension 3. So these are the 4. 1, 2, 3. This one is also going down like that. Now that you know how vector analysis works. You just have to resolute these forces into their X and Y components. And then, sorry, you are done. All right. So let's branch this into X and Y component. So the force, let's start with the first tension, tension 1. Okay. Tension 1, this force here, it has got the X and it also has the Y. The same thing here has got the Y, also the X. So in the X, we always talk about the cosine, and in the Y, we always talk about the sine. So we always get the angle from the positive X axis. So meaning our angle is this. You can also use 37 if you know the directions, which is still the same thing. Okay, whether you use whatever that you can use, is still the same. Don't worry. So X is going in this direction, so X here is negative. Here X is positive. Here Y is positive and there Y is positive. So the only thing here is that X is negative. If you use the way that X is negative, meaning you can use 37, like the way I'm going to do it. So I'm going to add the negative because the X here is negative. Then I'm going to say tension 1. I'm going to add cosine 37. Then I'm okay. The Y is positive, so that will be positive. Tension 1 sine 37 degrees. Let's go to tension number 2. Tension 2 is here. Everything is positive. So we have positive T2 cosine 53 degrees. Then we have positive T2 sine 53 degrees. Tension 3. Let's go to tension 3. Do we have tension 3 in the X? No, tension 3 is just here in the Y, which is negative. So here is 0. So in the Y, it's negative because it's going down. So we have just, now what's the value of tension 3? Tension 3 is actually the weight here. So that the weight will just be negative now, times 0, 0, 10, 2 newtons. Are we there? Then add the X component, add the Y components. So let's form the first equation. Okay, so the first equation is that we are having, so let's say sum of forces in the X will be equal to, we add everything in the Y, sorry, in the X. So in the X, we have T2 cosine 53 minus T1 cosine 37. And forces should always give you what? 0. And equation number 2, which is forces in the y direction. So in the y, we are having T1 sine 37 degrees plus T2 sine 53 degrees, then minus 1.00 times 10 to the power 2. This should give us what? 0. These are the equations that we need to help us find T1 and T2. T3 is known already, okay? Keep in mind, FG is just equal to tension 3. And this one is simple because the weight will always be downwards, and then the opposite force, remember Newton's third law of motion, there will always be an equal but opposite reaction force. So this is the tension force. So the tension force is acting in the opposite direction as the weight. So the weight is going down. In as much as it is pulling down, it's the weight, but the tension is acting upwards. Now that we've formed the equations, we need to make one of these. We can solve them simultaneously. By now, you know how to solve simultaneous equations. So we can make any of the T1 or T2 as the subject of the formula. So let us proceed. The easiest one that we can make is, I can use this equation, equation number 1, which is saying T2. So I'll proceed. Cosine 53 degrees is equal to T1 cosine 37 degrees. You've seen it, right? So I want to make T2 the subject of a formula, or T1, whichever I'm comfortable with. So I'll divide by cosine 53 degrees. I'll divide both sides by cosine 53 degrees. So you cancel, then you say your tension 2 is tension 1, you open the brackets. Remember that this is cosine 37 degrees over cosine 53 degrees. Of course, this you can punch on the calculator. Let me just punch direct on the calculator, and I'm getting T2 is equal to 1.3. I'll leave it to 2 decimal places. Multiplied by tension 1, because tension 1 is already there. So this is what I have come up with. So now I'll go in equation, the way we solve simultaneous equations, I'll go to equation number 2 and replace where there's T2 with 1.33 T1. So let's go equation 2. So we know that it's T1 sine 37 plus, here where there's T2, I'll put 1.33 T1 minus 1.00 times 10 to the power 2, and this should give me 0. Now let me solve for T1. So we can actually punch sine 37 easily on the calculator. Oh, I've forgotten something here. Sorry. There is this here, sine 53. Thank you. Minus 100 times 10 to the power 2 equal to 0. All right, now let's solve for T1. All right, just grab your calculator and punch everything for me. So you're going to punch sine 37. Okay, like sine 37, it's like 0.6. So I would say this is 0.60 T1 plus, I would say sine 53. So sine 53, but remember that this is multiplying 1.33, so say multiply by 1.33, I'm getting 1.06 T1 minus 1.00 times 10 to the power 2. This is equal to 0. Now I need to add these two, so 0.6 plus 1.06, I'm getting 1.66 T1 equal to, I can take this to the other side, meaning 1.00 times 10 to the power 2. So divide 1.66, and I'm going to get my T1 as, so 1.00 log there, 2 divided by 1.66, I'm getting 60.2 newtons. That's what I'm getting. as my tension 1. But how do I get tension 2? I'll go back to there. I know that my tension 2 is 1.33 multiplied by tension 1 is 60.2. So I'm getting 60.2 multiplied by 1.33. 60.2 multiplied by 1.33. 80. So tension 2 is 80.1. I'll leave it to, newtons. Done. So we have found T1, T2, and T3 was given in the question as 0 times 10 to the power 2 newtons. Just like that. Please subscribe and follow for more.